everyone, welcome back to my video. We are still discussing on chapter 1. So now let's continue. During my previous video, we are already talking about number 1, 2, 3 and 4. Now let's move on to number 5, which is factors affecting enzyme activity. So there are few factors that affect enzymes work. Some of the factors may cause reactive reaction because of the change in the structure. The reason of structure changing is because enzymes, which are proteins, are sensitive to certain conditions due to the bonds that hold them together in tertiary and quaternary structure. So what are the factors that affect enzymes activity? There are pH, temperature, enzyme concentration and substrate concentration. So factor number 1 is pH. Each enzyme has optimum pH at which it attains its maximal activity. Look at the diagrams. The optimum pH for pepsin is approximately 2, while the optimum pH for trypsin is approximately at 8 value. Alright, if you have too high or too low pH condition, the enzyme will denature and there are fewer enzyme substrate complex form. Look at the graph. You see that there is sharp decrease in the rate of reaction because pH will influence the charge of the amino acid in the active site, and of course hydrogen ion concentration and the ionic bonding of enzyme. Any changes of pH below or above optimum pH will decrease the rate of reaction, and changes in pH lead in the changes in the ionization state of substrate or enzyme or both. Second factor is temperature. If the temperature is too low, there are not enough kinetic energy for successful collision between molecules of enzyme and molecules of substrate. As temperature increases, the kinetic energy of enzyme and substrate also increases. Substrates collides more often with the active site of enzyme, so rate of reaction increase at optimum temperature. If the temperature is too high, atom enzyme molecules will vibrate violently, breaking the bonds which hold the molecules in their precise shape, so enzyme will denature and lose its catalytic properties. As you can see here, there is sharp decrease of the graph due to the denaturation of enzyme above optimum temperature. The third factor is enzyme concentration. At low enzyme concentration, there is great competition for the active site and rate of reaction is low. As enzyme concentration increases, there are more active site and reaction can proceed at a faster rate, and the rate of reaction is proportional to the enzyme concentration. Look at the graph, provided that temperature and pH are constant, or you have optimum temperature and optimum pH, substrate concentration higher or sufficient. And the last factor is the substrate concentration. The rate of reaction increases with increasing substrate concentration. If there is low substrate concentration, the rate of reaction is low, and then there are positive correlation up to a certain substrate concentration. We call it as point of saturation. At point of saturation, further increased substrate concentration produce no significant changes in rate of reaction. So the rate of reaction become constant, and you see the graph become plateau. We call it plateau. Look at the graph. The straight line is the plateau. The rate of reaction constant. Alright. Here is another example of how substrate concentration affect enzymes activity. Alright, during A, here, there are many enzymes molecules but few substrate molecules, therefore rate of reaction low. While in B, during B, when there are lots of substrate molecules, the reaction proceed at a faster rate. Okay, up to a certain point, up to a certain substrate concentration, the reaction reach at point of saturation at B. While during C, there is a lot of substrate molecules but there are no free active site, so enzyme concentration becomes limiting factor. The rate of reaction become constant and the graph showing plateau.